Hey, everybody. It's Monday, April 18th, 2022. We're back from spring break. This is Intro to Statistics. We have been doing hypothesis testing. In a previous chapter, we looked at doing hypothesis tests for one sample group with both proportion and mean. And then the last thing we did before you guys went on break was we looked at doing a proportion test for two samples. Today we're going to start looking at doing means for two samples. So section 11.2 is today's topic. And this is called the paired samples test. Or a dependent test for two samples, for the mean for two samples. Okay, and let's just talk about why we're doing this one. On Wednesday, we're going to do it where they're not paired, where they're independent. But where would a circumstance arrive where we want to use something that's paired? So if we wanted to compare, let's compare like Motel 6 versus like a Hampton Inn, which is kind of like part of the Hilton group. And let's look at doing it in San Francisco versus, say, Fresno or Visalia. So Motel 6 is an inexpensive place to stay. Well, it's all relative, but it is one of the least costly places to stay when you're on vacation. And Visalia, compared to San Francisco, Visalia is going to be less expensive also. If you want to go to Motel 6 is usually like 1.5, 2 stars. It's on the lower spectrum. The Hampton Inn or any of the Hilton like places, it tends to be, 3 or 4 stars, a little more costly. And that's the same thing with San Francisco. San Francisco, it's more expensive to stay the night just because of where it is. So we could look at staying the night at a Motel 6 in San Francisco versus like a Hampton Inn in Visalia. The Motel 6 is less expensive, but it's in a costlier town. It was I think when I looked it up, this was about $115 a night. And when I looked up Hampton Inn, I saw one in Tulare, so I'll put Tulare. Hampton Inn in Tulare, it was $136 a night. Now they're not exact, they're not exactly the same, but they're fairly close. But are these reasonable to compare? Can I compare these two? Or even put them in the same category? Is staying at Motel 6 as desirable as staying at a Hilton or Hampton Inn? No, it's not. No. A lot of people will just flat out say, no, I won't stay at a Motel 6. Whereas others will. It's a good place to, if you've got pets and you're trying to save some money. But it makes more sense to compare. Like, I don't want to compare a Hilton with a Motel 6 just because they're in different towns and they're about the same price. They're in different towns. So I shouldn't compare hotels in different towns and go, which one's a better deal? You're not, those aren't your options. So maybe we should stick to the same town. So maybe we should focus on location. And we definitely don't want to compare San Francisco to Tulare, because who wants to stay in Tulare? Who wants to stay in San Francisco? There's a lot more stuff to do in San Francisco. So this is where the idea of a paired test comes up. What we're going to do is we're going to look at both hotels. And we're going to compare them together. But since, as we've shown, that being in a different location can have different effects on the price, we're going to pair them up by pairing them based on location. Now, most cities don't have, 50 hotels of Motel 6s. So we'll have to choose different cities, but maybe let's just take a Motel 6 and a Hilton from like each town and do a bunch of towns that way. And this is what a paired test is like. So we're going to take a look at doing that. Let's explore what we need for this 2-sample paired test. This will be a paired test. And let's just compare the means. I claim that the Hampton Inn is higher. I am off screen, and let's see, can I fix that? God, I don't like that. That worked. I claim that the Hampton Inn has a higher cost. Now, I think this is kind of a no-brainer. This is an obvious thing, but it's more of a way to set up an example for doing a 2-mean test. And then we'll look at some other ones where it's more applicable. I'll give you a second to write that down before I switch pages and start talking about our requirements. If you need this up longer, holler. All right. So this 2-sample paired test, or the paired test, or 2-sample mean test. Or 2-sample dependent mean test, or Now, keep in mind that we are doing a hypothesis test. So remember, we want things to be normally distributed. Samples, that's the best option. Or we need to meet certain criteria. And when we did this with one mean, what we wanted is let's see, I need a good color. Let's go with green again. We wanted our sample size, remember our sample size needs to be greater than or equal to 30. Or it needs to be approximately linear. With no outliers. And this is one we checked with the QQ plot and the correlation statistic. And no outliers, we could check on a box plot. Now that was how we did one mean. How does this translate to two means? Well, the translation to two means is much the same. Now I want N1 to be greater than or equal to 30, and I want N2 to be greater than or equal to 30. The two different groups. Or both groups to meet that criteria above. Okay. And we have a couple more in addition. These were our one mean requirements. And now we're looking at our two mean requirements. So we want those for the one mean or for the two mean. But since it's a paired test, they actually need to be paired up so that like every member in the first group, there is a pair to it in the second group. Since the members are paired, it means we should have the same sample size. N1 should equal N2. If I've got 30 Motel 6s and 31 Hiltons, I can't pair them up. Okay, so we need to have it like that. They got to be paired. Okay, and that's something that's added. And two, there needs to be a dependent relationship between them. In our problem, in the hotel problem, the dependence is city. Okay. Let's go over and take a peek at StatCrunch real quick and illustrate, take a look at where we're going to go. So since we're doing a means, we're going to go T-stats. And we're going to choose paired. And this is in StatCrunch. Now notice what happens when we got two sample, which we'll do on Wednesday, and one sample. In both of those cases, it prompts us for with data or with summary. I can choose between them. Paired, I'm not given that option. So that's another, since it's paired data, we actually need the data. Which means no summaries. Like two sample or one sample, we could say with summary. We can't do that with the paired test. Okay. This actual requirement can actually help you when you're trying to figure out what kind of test to use. So if N1 does not equal N2, there's different sample sizes. It can't be a paired test. Okay, can't, because you have nothing paired. If they're different sizes, you've got no pairs. And then if N1 equals N2, then you have to, you still have to check for dependence. Between the two groups. Give me a chance, second to write that down. Everyone ready to go on? Okay. Oh, I see a chat thing. Yes, yes. Okay. What else was I going to say? I was going to add something to it. Oh, yeah. So I said if N1 equals N2, you have to check. Let me give an example. Example. 100 boys and 100 girls are surveyed. About if they use TikTok. Let's say we have all the data. For each group. And we're trying to decide if we can do a paired test or not. Now, if I call boys group 1 and girls group 2, they're both 100. Why is it still giving me glare? So here, N1 equals N2. And we have the data. I didn't list it, but we have the data. Is there a dependence listed? In this case, there's nothing that actually indicates that they're related. Now, if we said we asked brothers and sisters, then yes. But as the question is worded, the way the question is worded or the information we have, no. So we'll look at doing that type of test on Wednesday. That's just a regular 2-sample mean test. That will be stats, T-stats, 2-sample. That'll be Wednesdays. Today we're doing paired though. So I'll just bring up the pair. I don't have any data in there, so I can't do anything with it yet. But I'll just show you what it's looking for. Okay. What does StatCrunch want? StatCrunch needs column with group 1's data, a column with group 2's data, and that's it. Notice the setup. It says the hypothesis test. It gives H naught. It says is mu D equals mu1 minus mu2. This is very similar. This is like the P1 minus P2 that we did before. From the 2 proportion test. Okay. And they use that D for difference. Difference means subtraction. So mu D is mu difference. It's like what is the mean of the difference? So what they do is they go through and they take all the pairs of data and they subtract them. And they take the mean of that difference. So we'll see that working out in a second when we put in a problem. And then, of course, the default, we can change the default to 0 if we want to say they're about the same. But maybe with this Hampton and this Motel 6 thing, I'll look at something different. I'm going to come over here. I got the lecture notes loaded up from the file section. And let's see. We'll do this group right here. Can you zoom in? So this says the following data represents the city cost of a one-night stay in Hampton versus La Quinta. So they chose Hampton and La Quinta for this problem, more because they tend to be more closer in price than Motel 6 in Hampton, but not always. So let me move that where we can read it a little bit better. Test the claim that the Hampton Inn hotels are priced differently than La Quinta Inn hotels. Okay, and they did 10 cities. And let me write down the numbers here real quick if we need them up. That way I can type them in a little bit easier. So my Hampton and La Quinta. Let's see, I'm going to do, there's 10 numbers. So I got 129, 149, 149, 189, 109, 160, 149, 129, 129, 119. And they're telling us the pairs are based on these rows. The top row is doubts. So I don't actually need the names of the cities in there when we're doing the calculations. I just need to make sure that they're paired up correctly. Let's see, 129, 149, 149, 189. I'm just checking my numbers real quick. It's always a good idea to double check your numbers before you run with them, because you're going to get the wrong answer no matter what you do if you start off with the wrong data. Okay. So having said that, let's get that. Let's see. I might be able to copy and paste it over. Gosh, this would be nice. Oh, nice. So I'll call this Hampton. I was able to copy and paste. Otherwise, I got to type it and make sure it works. So I'll pause for a second and then we'll walk through the steps of the hypothesis test and make sure we're doing it correctly. You guys ready for more? Just holler if you need it up longer. Otherwise, I'll move on. If you need it up longer, I'll pull back. So, hypothesis test. Let's do our test. Ah! Whew. All right, so step one is identify H naught and HA. Right? So H naught is always a statement of equality. And for the paired test, it's mu D equals 0. And mu D is mu1 minus mu2 equals 0. And the other one, we got to see what the wording was on the example. The wording said price differently. It didn't say Hampton Hills were higher or lower than in cost. It just said differently. So we're going to go with not equal. So here we actually have a little of an advantage. It matters less which group we call H1 or group 1 and which one we call group 2. But I think to be safe, I'm going to label them. And since they're already in an order, and it doesn't matter what order I use, I'm going to call group 1 Hampton. And group 2 is La Quinta. Step 2 and step 3 are sort of connected. We can't do anything until we have both. I'm going to put step 2 as state alpha, or the level of significance. And in this problem, they actually tell us what it is. Alpha equals 0.05. So I'm going to do that in red so I can find it a little bit easier later. Step 3 is get the test statistic and the p-value. And for that, we go to StatCrunch. So I'm going to come in here. I'm going to go stats, T-stats, paired. And I'm going to tell it Hampton will be group 1. That's what I chose up here. La Quinta will be group 2. I don't need to save the differences. I don't need to store in data table. Actually, I'm going to save the differences so I can show you where it comes from. We don't need to store in the data table. We don't need to show the critical value. We're just going to click compute. So when I click compute, it gives me my T-stat is 5.2715561. And it says my p-value is 0.0005. It says the differences are stored in the column differences. So notice they made a column difference here. And they gave me a mean of 51.4. I wonder where they got that. Let's see if we can figure that out. So the difference is they just take group 1 and they subtract group 2. It's based exactly like what it says right here. Group 1 minus group 2. So 129 minus 105 is 24. 149 minus 96 is 53. And it goes down the list. And it does them all there. And then it kind of does its test on this information right here. What is the mean of that column? The mean of that column is the 51.4 we saw in the paired test right here. So that's how they're going about doing it. That's just for a little bit of insight in how they're comparing them. They find the difference between the two. So back to where we were. Step 4. What is step 4? Step 4 of a hypothesis test is make a decision. Do we support H0 or do we not support H0? Do we reject or do we not reject H0? So remember, we're going to check p-value versus alpha. So what do I have here? My p-value is 0.0005. My alpha is 0.05. It looks like p-value is less than alpha. So when the p-val is too low, reject the hoe. Or if you don't like saying that, the null must go. So when we reject H0, means we're going to support HA. That's our decision. The one that we didn't choose, as just a refresher memory, is when we do not reject H0, we do not support HA. And we didn't do that one, so no on that one. And step 5 is always about HA. Step 5 is a statement of conclusion about our decision with HA. So here we chose to support HA. And that's not what we're going to say. We're civilized, educated people, we're going to make a full sentence. Since we're supporting it, there must be enough evidence to support it. So there is sufficient evidence to support the claim that Hampton Inn hotels are priced differently than La Quinta. That would be my final answer right there. That's the final, like that's what we report to the press. Before I continue though, there was something I failed to do. Does anyone know what I missed? Any ideas? I didn't check my assumptions that it's normally distributed. Assumptions or requirements. Normally distributed. And the problem didn't say anything about that. So we got to look at our sample size. Are the sample sizes bigger than 30? No, they're not. So samples are not, N1 is not greater than 30. N2 is not greater than or equal to 30. So I got to go through and do a couple other things. One of them was the QQ plot. We'll start with, and the other was a box plot. Box plot's at the top of the list. I'll start there. I'll do a box plot. I'll do each of these. I will draw boxes horizontally. And Hampton Inn had an outlier. Look at that. So I probably shouldn't have used this test. So at this point in real life, you would maybe go get more city samples because all you need is information from 30 cities. And you can actually find this information online. So we could fill out our list a little bit better. So it's worth pointing out that even though I had the data, I didn't have enough data. I didn't meet it. We could look at the QQ plot though. Let's take a look at those. We'll add correlation statistic. We'll do normal quantiles on the y-axis. And that all looks pretty linear. And that one looks pretty linear too. So it might still be good, but we just don't have, we can't guarantee it because of that outlier. Any questions on that one? No, okay. All right, so let's load up another one. Oh, look at that pretty one. That's a pretty short. That shows, oh, that's the normal probability plot on the difference. That's pretty nice. That's probably better than what I did. Let's see. We do that on that difference column. It looks even better. It's more linear. And if we do a box plot on that one, yeah, there's still an outlier. Undo. There we go. How does it not show an outlier on this one? I don't understand. We have an outlier on this one. All right, next one we're going to look at. So let me zoom this out a little bit. Not enough further, or open this up. There we go. So a quality control manager at an amusement park. Drop the pen. Hold on a second. That the quality control manager in an amusement park feels that the amount of time that people spend waiting in line for the American Eagle roller coaster is too long. To determine if a new unloading procedure is effective in reducing the wait time in line, he measures the amount of time in minutes people are waiting in line on 7 days. After implementing the new procedure, he again measures the amount of time in minutes people are waiting in line on 7 days and obtains the following data. To make a reasonable comparison, he chooses days when the weather conditions are similar. And it looks like he is choosing the same time of day with similar weather conditions. So I'm assuming it's the same season. And so he's got Monday, he does some at 2 o'clock, Tuesday at 2 o'clock. On the weekend, he does 11 a.m. and 4 p.m. Check 2 different times. I guess it's not as busy in the morning as it is in the evening. And then he does the same thing with Sunday. So what is he trying to figure out? If a new procedure is effective in reducing the wait time in line. Now remember, we're going to have to do, I'll get that data up and back up in a second. Actually, I'll shrink it down a little bit more. And let's just talk about it over here. So we've got 2 groups. And group 2. And I don't know which one they are. But he thinks that the wait time will be reduced if they implement the procedure. Now, one way of thinking that is going, the wait time before has to be bigger than the wait time after. Does that make sense? So if they had to wait 10 minutes before, if the line is good at reducing wait time, it should be less than 10 minutes. So like the after wait should be lower. So if I subtract one over to get it on the same side, so I can do wait before minus wait after is greater than 0. This gives me a way of picking which one I want to call group 1 and group 2. Since we're going to do a paired test, it looks like this is paired by time of day and weather conditions. There's a dependence there. I'm going to go with this is mu1 minus mu2 greater than 0. So group 1 will be my before times. Group 2 will be my after times. Okay. Let's get this data copied over and put into StatCrunch. I hope I can copy and paste it. Let me make a new worksheet real quick. Ah, hell. Okay, so pro tip when this happens for you. If you can't copy and paste as is, like it's in row form, not columns. What you can do is you can tell it, we can make it flip it. So StatCrunch can make, we can turn rows into columns. And it's called transposing them. Excel has this too. In fact, I'll show you the Excel thing afterwards. In StatCrunch, it is data, arrange, transpose. So that's what I'm going to do here. Data, arrange, transpose. And I need to tell it all the columns I'm working on. So how many columns does this take up? It goes up through variable 9. So I'm going to do stat or data, arrange, transpose. I'm going to tell it to do 9. Oh, it highlights all the ones with data in it. That's nice. I can open it in a new data table. That will make it the least messy. All right, notice what it did. It calls this label. It's got 11.6 up here, 10.7 right there. If I go back and look at the other graph or the other table, 11.6 and 10.7 were paired up. So I need to add that back in. I'm going to add in another one. I'm going to add in 11.6 here and 10.7 there. And that was my variable 1. I don't need to put them in the same order as long as they're paired up correctly, side by side. So we're going to go, I want to see if it works. So I'm going to do the stats, T-stats paired. I'm going to tell it the groups that I said before. Oh, I need to relabel them. So which one is the one with 11.6? 11.6 is the before data. 10.7 is the after data. So this is before. This is after. Since I don't have n is greater than or equal to 30, I want to do some of that plotting on it. And I'm going to put that difference thing in like we had for the other group. Before and after. And I got mu1 minus mu2 is greater than 0. I'm going to click that now. I'll come back to it though. Oop. Options, edit, save the differences. Okay. So now let's do a graph QQ plot on the differences. Fairly linear. The correlation value is high. That's good. That's a good sign. And we can look for a box plot. And another outlier. So maybe this isn't the best data set to use, but again, we're going to go with it anyways. Let's just assume that it did work. So I'll redo this test. We're going to go stats, t-stats, paired. And we're saying, we said group 1 was before, group 2 was after, and we want mu1 minus mu2 to be greater than 0. So it gives me some data. I need to actually start going through my steps here. Let's state what H0 is. H0 is mu d, which is mu1 minus mu2 is equal to 0. HA is mu d is greater than 0. Or mu1 minus mu2 is greater than 0. Okay, that's step 1. Step 2 is identify alpha. I think they gave us one in the problem. Is the loading, unloading procedures effective in reducing wait time at alpha equals 0.05? Look at this. So they didn't want me to actually check it. They said a normal probability plot and box plot of the data indicates that the differences are approximately normally distributed with no outliers. So even though that wasn't true, we're going to pretend like it was true. When they give you this information, it's usually saves you some time to roll with it. This was put in the lecture notes so that we could go ahead and do it. I'm pretty sure I know what was screwing everything up is this Saturday, 4 p.m., which has got times much different than any other time. Way larger. But it says we could do it. A normal probability plot worked. All right. So I had my step 1 was my H0 HA. Step 2 was this. Step 3 was our test statistic and p-value. We got that right there. My t-stat is 1.2199556. And my p-value is 0.1286. Notice I'm writing everything down. If you're doing a paper, or doing something, write down as much information as you can. You can always edit it down later on if you go, okay, I want everything to 5 decimal places or 4 decimal places at the end. You can always go back and edit the numbers, do rounding, but you can't unround shit later on. Once you rounded it, there's no going the other way. So do rounding at the end if you really want to round. Keep all the data for now. All right, so I got my p-value, I've got my alpha, I've got my test statistic. Let's make a decision. Is p-value less than alpha? 0.1286, is that less than 0.05? No. So the p-value is not too low. So if the p-value was too low, we would reject H naught. Since it's not too low, we don't reject H naught. And since we're not rejecting H naught, we're not going to support HA. And HA was that implementing those procedures would reduce the wait time. So that's what my statement's going to be all about. There is insufficient evidence to support. At this point, I'm going to go back and read the actual problem and kind of quote what I can there. There's insufficient evidence to support the quality control manager's claim and I got the question right here. That's his claim. So there's insufficient evidence to support the quality control manager's claim that the loading unloading procedure is effective in reducing wait times. Any questions on that one? All right, so let's take a look at one of our homework problems. Let's do number 11 from section 11. There it is. Okay. So it says to test the belief that sons are taller than their fathers. I'm going to write that down. That seems pretty effing important, doesn't it? Sons are taller than fathers. That's the belief. Seems like the point of this problem. I don't know why I use an apostrophe. It's not possessive. Sons are taller than their fathers. A student randomly selects 13 fathers who have adult male children. Well, that's a good idea. You want your children to be adults also. You can't compare a 12-year-old boy to his dad. That's not right. I'm assuming the student was the she records the height of both the father and son in inches and obtains the following data. The question is, are sons taller than their fathers? That's what it says right there. It gives me alpha I'm gonna write that down. I think I know I need that. Alpha equals 0.01. And it says, note that a normal probability plot and box plot of the data indicate the differences are approximately normally distributed with no outliers. That's good to know. That means we don't have to do our tests. So I got to come down here, and what's it asking me first? Which conditions must be met by the sample for this test? Select all that apply. Well, we want the sampling methods to result in a dependent sample because this is a paired test. They need to be paired. And we wanted the differences to be normally distributed or sample size is large. That's true. Anything else that we want to add? In general, we don't want n to be bigger than 5% of the population size. So I'm going to click that one. I'm pretty sure that's going to say, yes, it's going to take that one. And it does. It says, let's go with that. It says, let D1 equal X1 minus Y1. I need to know what the data is here. So X1 is fathers, not X1, XI. So XI is fathers. And YI is sons. And so that's what the order we're going in. We're doing fathers minus sons. So if it's fathers minus sons, I'll come back to the data in a second. If it's fathers minus sons, let's go back to the wording of the question and see how that's going to look. So sons are taller than fathers. If I were to write that, I would say sons are taller than fathers. Alternatively, I can flip this around and put fathers on the left and say fathers are shorter than sons. These are interchangeable. I think I'm going to go with this one because then I like subtracting from right to left for some reason. When I subtract the right over to the left, I have fathers minus sons is less than 0. And fathers is XI. Sons is YI. So XI minus YI is less than 0. That's my HA. Which means my H naught is XI minus YI equals 0. Now notice they kind of did it all wonky. The belief is sons are taller than fathers. And then they want us to do fathers as the leading group, which means we got to have a less than sign. And I wrote out the sentences. I wrote out this sentence as a symbol in symbols just so I could figure out, which way that sign's got to go. Because intuitively, I wouldn't just automatically put taller makes me think greater than, right? You're taller than, you're larger than, your height is more than, or greater than. So I would want to use that one, but they said use fathers first, so we got to end up with a less than symbol. So that's what I'm going to enter in. Mu D is of course 0, and mu D is less than 0 is what we calculated. Because remember, this part right here is mu D. Okay, they want us to do more of the stuff. So I've got my step one right here. Step one's done. I got H0 and HA. I've actually got alpha up there too. I've got alpha is 0.01. Let's not lose that. That's one of the things we need to do. It's now asking us for the test statistic. So I'll come in here and I'm going to say, hey, load this in StatCrunch because I don't want to hand type it over. Heights of fathers, heights of sons, booyah, all done. We can go stats. I'm going to make that window a little bit bigger so it's easier to see. Stats, T-stats, paired. My first group is the fathers. The second group is the sons. And I want to go with less than. That's what we decided on. And I'm going to click compute. And my T-stat is 0.028716572. And my p-value is 0.5112. Those are the two things I needed right there. The two right columns. So I can come back over here and answer the questions. I didn't know how many decimal places they wanted. Two decimal places would be 0.03. And I put O. There we go, 0.03. And my p-value, they said, let's do 3 decimal places here because they are jerks and change the number of decimal places mid-problem. And now, should the null hypothesis be rejected? Let's take a look at that. Let's think about it through. I've got my p-value right here. My alpha was 0.01. What symbol goes in the middle? Is it greater than or less than? Anybody? That's right. It's greater than. So the p-val is not too low. Which means we don't reject H0 and we don't support HA. So they want us to put that in. And we decide we're not rejecting H0. So it says H0 here. We're going to say we do not reject H0 because the p-value is greater than the level of significance. Now they want us to do they're doing our sentence here. So let's go to our sentences. We don't support HA. HA was that sons are taller than their fathers. There is insufficient evidence to support the claim that sons are taller than their fathers. It seems like a silly belief. Why would you believe sons are taller than their fathers? I mean, it does happen, but there's no reason that should just be a general rule of thumb. Otherwise, we would constantly be growing as a species. We'd be giants by now. We'd be enormous. All right, so we want to say there is not sufficient evidence to conclude that sons are taller than their fathers. We click check answer and bam, done. Any questions? All right. Well, that's going to wrap up today's last lesson. Oh, we got, nope. You've got no. All right. Well, then I will let you go and get started on your homework early, or your project if you're still working on it. We're running out of weeks, guys. Just a few weeks away. Let's go look at the calendar real quick before I send you packing. Let me close that. And I don't want to use that one. Let's go look at our calendar real quick. Let's see. All right, so let's see when the finals due. The 15th of May. The last days of class is Tuesday, May 10th. Let's look over here on the calendar. Can you guys see my calendar when I open it up in the window in the lower right? I'm hoping you can. Let's see, we've got 2 more weeks in April. We've got the first week in May. So that's 3 weeks. And so like Monday, May 9th is 3 weeks from today. Is that right? On the 18th, 1 week would be the 25th, 2 weeks would be the 2nd, 3 weeks would be the 9th. Lectures are done in 3 weeks, and the final starts in 3 weeks. You've got on the Wednesday through the Sunday at midnight. So we've got 3 weeks of class left. It's time to double down and start getting stuff done. If you're falling behind, you got to catch up. Do it for all your classes. Dig deep. You can do it. Okay. If you've got questions, don't be afraid to send me a holler. Use ask my instructor in my math lab. If you're working on your project, you got a question, email me your question. I was answering questions over the spring break for a bunch of students. Where am we going? Stop share is what I was going for. There we go. But that's it. You guys are almost done. You can do it. Have a good day.